right, ye laggards, grab your seats. Let's close the door just because it's a little bit loud outside. Oh, thank you. Cheers. All right, let's get started. So, hi. Yep, all good? Cool. My name is Gabel. I work for an Israeli company called Wix. I'm going to talk more about the company and its products than I'm used to, but it's not, sorry about this. It's not a sales pitch, it's for context, because what we're actually going to be talking about, event sourcing, is a very useful pattern that we've been employing lately, and I'm going to use one of the services that we've built at Wix as sort of a running example to provide context for this. A few trivia first. If you have any questions, either use Slido, which shows up on the screen there, there's a link, or just raise your hands and I'll pause. Don't wait for the end. If you have any questions, if anything isn't clear, just raise your hands. I'll hopefully notice you and pause. It's no problem. The more interactive this is, the better. So don't be shy. Also, I'm pretty sure that's it. One other thing, everything I'm going to be talking about is implemented as sort of a standalone borderline production grade implementation in Java based on Dropwizard. There's a link at the very, very end of the slides to the GitHub repo. Also, I linked to the slides on Twitter. So if anyone can't see the screen, just check out the buildstufflt hashtag, and it's linked there from the last hour or so, and you can follow along. With that, let's get started. So, a little bit of background. I'm going to be talking about a particular product that we've built called Wix ADI. It's one of our two flagship products at Wix. Now, ADI is a site builder. So fundamentally, if you're not a technical person and you want a website, and you're sort of beyond non-technical, right? We have two flagship products. One can be thought of as like PowerPoint for the web. You want to build a website, you can use PowerPoint. Awesome. You can go to wix.com. You can, run around, you get an editor, everything is online, you click publish, you get a site. ADI is slightly different in that it aims at sort of a less technically savvy crowd. It's more like wizard oriented, and we sort of build the website for you and then you can customize it. But fundamentally the product is a website builder. Now it's a pretty cool product. I'm not necessarily advocating you use it, but it's cool in that it's a pretty big code base. Most of the heavy lifting in Wix ADI happens on the client side, right? It's a huge app. It does a lot of things on the client side. The server is actually remarkably stupid compared to what you might be used to. I guess this is the 21st century or something. It even works, which is pretty cool. But having a cool web app, big though it may be, impressive technically though it may be, is not enough, right? Fundamentally, people are building sites based on this, based on this product. These sites have to be stored somewhere, right? Eventually, all those bits that comprise a site have to be, sent to a server, stored on a hard drive somewhere. You can't really ignore it. You can't not have a server side for these kind of things. By the way, if anyone is thinking serverless, I have a rare condition which prevents me from pronouncing the less in serverless. It's called common sense. But that's a completely different debate. So, as with any product, the first thing you do, okay, let's assume for a second we, as in every single one of us, is a server developer at Wix. We are tasked with designing and implementing the server for this product. So, as with any sort of new greenfield project, the first thing you do is you step up to your product manager. And then you ask, what is it that the product does, right? What are the fundamental requirements for this product? So we have three kind of chief requirements. First of all, like I said, basically most of the heavy lifting is on the client side. The server is mostly charged with just storing the sites. So in many ways, a site is just a blob. The server doesn't really know that much about the details of what a site is, what the pages are, what the data is, the text, the components, all these things. The server does not care about at all, which makes our life way simpler. Fundamentally, this means that our chief product requirement is we need to store these blobs. And we need to store a version history of these blobs because, as you might know, doing software engineering, people screw up. And when you screw up, you want to be able to undo. You want to be able to revert, right? So we need to implement the mental equivalent of a source control so that when people screw up, they can, just walk into their admin interface, go like, oh shit, I really screwed this up. I want to, go back to the version of my website from yesterday. So version history is a thing. We don't delete any data, right? So it's all soft deletes for a variety of reasons, not the least of which the fact that users are stupid. So they tend to do things like delete their sites unintentionally, and then they want to roll back to a version that actually exists. So we don't get to delete any data either. One non-requirement that we have, and this will hopefully, we'll circle back to this, so it'll make a bit more sense further on in the talk, is we are not required to support concurrent editing, right? So one user, 2 tabs, or 2 users working on the same website, not a supported mode. This is actually more common than you think. So for instance, if any of you use WhatsApp, like the desktop or web app for WhatsApp, you can't actually have more than one live session of WhatsApp sort of web application online at any given time. So it turns out that for what you might consider simple products that are intended to be used by one person, this actually makes a lot of sense. And as we will circle back to, makes our life considerably easier. Now, being under the hat of server-side software engineers, when we get these requirements, the first thing we're going to start doing is, we're going to start thinking architecture and data modeling and all that stuff. And the pattern that we all know and love for building these systems is called CRUD. And CRUD kind of sucks. I'll just put that out there for a minute so you can read the beautiful dictionary definition. For those of you who can't see it, CRUD, among other things, means a substance which is considered unpleasant or disgusting, typically because of its dirtiness. That is a very apt analogy. And here is why. CRUD, right? Create, read, update, delete, the most trivial of models, what we all do kind of every day on our databases. The main problem with CRUD is that it's all about mutable state. And this should come as no surprise to any of you, especially over the last few years. Shared mutable state is considered a bad idea for very good reasons. Why? Mutable state is bad, right? That's an assertion. Why is that? Fundamentally, it's because old data is lost, right? If you issue an update statement, right? You have a user database or something, and a user updates their email, and you issue an update statement replacing the column for email for that particular user, you have lost the old email, right? You lost the old data. What that actually means for you is that over time, and this is something that I hope will resonate with a lot of you, over time you start accruing these weird defects in the data, right? They might be a result of bugs or operational issues. You might have had to restore from backup and you have some dangling entities in your database. There's any number of reasons why this happens, and this is inevitable in any meaningful production system. The problem is, with a CRUD-based system, when you sort of get a support ticket from a customer saying, this feature does not work for me, you start doing your research, then you find that the data in your database is in some sort of invalid state, right? The only thing you're left to do is go like, how did we even arrive here? I don't know. And you start researching, you start forming hypotheses, you read through the code, you try to sort of build a mental model of all of the different interactions in your system. What are the various things that, like, what is a plausible scenario that got us to this invalid state? But you don't really know. You never really know, right? You always think, you always guess. And fixing it is even worse, because having arrived at your invalid state, you typically have this, once every few months, you find one of these things, and then you have to sort of sort through the data, you have to iterate through it, you have to come up with this heuristic to fix the data, right? Bring your system back to a valid state, which you think is what it was supposed to have been in the first place. And then typically the fix doesn't quite work, and you have to iterate on it, and you might have actually ended up causing more sort of damage to your data than you started off with. So CRUD-based systems over time actually make it really, really, really hard to debug data issues and fix those issues. And finally, you have no built-in auditing. So this might not seem like a big deal. And for a lot of systems, it isn't, because most systems do not have auditing as sort of a first-class product requirement. right? If you're not in a regulated industry, or if you don't know ahead of time that you care about the old data, then you're probably not going to build in auditing in the first place because, it's extra effort and you ain't going to need it. Now, here is one quote from Gregory Young, who's heavily associated with this conference, that really resonated with me a few years back when I watched his sort of one of his initial event sourcing talks. Who told you you're allowed to destroy data? Whenever you're updating data in your database, you're destroying the old data. Are you allowed to do that? Maybe the answer is yes. Maybe the answer is no. The thing is, when we sort of, unthinkingly go into the traditional system architectures based on like CRUD techniques, we don't really ask this question. And therefore, we take it for granted that we are allowed to destroy data. We don't keep the old data. And it turns out that old data is remarkably useful, not just for debugging, not just for fixing stuff, also for doing behavioral analysis. Like your toy system is all fine and dandy. 3 years later, you have 500,000 customers. Suddenly, you really want the insight as to what these customers do. And if you haven't built ahead of time some sort of audit log or some sort of BI mechanism that sort of emits user events that you can then use to track how users actually use your system, you're just not going to know, right? You need to, at some point, arrive at the conclusion that this is interesting for you and then build those things in, and you will have lost all of the historical context for how your system evolved and how your users actually use the system. So not having an audit log, even if you're not in a regulated industry, is actually sort of a loss for you, right? Wouldn't it be nice if you had that data? The other fundamental issue with sort of the traditional technique with CRUD is that CRUD implies one single source of truth, right? You have your database, you have your users table or your sites table for whatever business domain you operate in, and that is the single source of truth, right? Everything you do against that data goes to one database. That includes your rights, and that includes all of your different read use cases. Now, how many of you, feel free to raise your hands if you like, how many of you have had this annoying experience where as your system evolves, you figure out new use cases, you want to add capabilities to the system, particularly sort of read use cases. You need, for instance, to add an index, right? And it turns out that you can't realistically add that index because that will, that generates a lot of load on the database and you need to deal with the locking stuff. And instead of just adding a new capability to the system, you end up wrangling your database for weeks on end just to get to the point where you can actually support that new feature. Even worse, typically after that, you find out that your write performance goes down the drain because suddenly you have 3 indices instead of 1. Right? So this is a very, very common thing that happens, and it's very unfortunate. More crucially, though, this programming model where you have sort of a canonical database for your entities and you do everything against that sort of leads you down the wrong path because the SQL model of doing things implies a very high degree of consistency, data consistency in the ACID sense, right? You expect that if you issue an update statement and a second later you issue a select statement, you will get the correct data, right? And that turns out to be very difficult to scale, and also it turns out to not really be required in a lot of cases. So, assuming you agree with me that you're losing data, you don't have auditing, and it's difficult to scale, let's think a little bit about what's holding us back. I assert that we have 2 major issues. The first is strong consistency, right? The SQL model, the one we all love and use every day, and it doesn't matter what database you use, it doesn't matter if it's MySQL or SQL Server or whatever. A traditional RDBMS sort of assumes a strongly consistent data model and a strongly consistent read model. This is actually oftentimes not required. It turns out that for the vast majority of product use cases, consistency is a tunable thing, right? For any given use case, right, you can approach your product manager and say, oh, would it be bad if this showed data that is stale for up to 5 seconds? right? For instance, let me give you an exact example, right? You have an e-commerce solution. You typically have your store, right? The thing your end users actually, fire up their web browser and go and have a look at your product gallery. And then you have your admin interface where people actually running the store come in and they update stuff. They add products. So if you added a product to the store, how critical is it that the next person coming into your system and viewing the product gallery can actually see that product? The answer might be it's super critical in some cases, but usually it's not a big deal if it takes upwards of a few seconds or even a few minutes for a new product to show up in the product gallery. And just having that discussion, having that relaxation of requirements, those easier guarantees, means that you now have at your disposal a much more open-ended kind of architectural decision to make. There are a lot more possibilities as to how to architect your systems if you don't assume full consistency all the time. And this is a discussion we're not used to having with our product managers, and they're not used to having it with us. Because if you approach your product manager today and you ask, how fresh does this data have to be, they're going to go, well, it's got to be fresh, of course. But if you tell them that the cost of having the data sort of fully consistent and totally fresh is, an extra week or a month or a year of development, suddenly that becomes a trade-off. And that is a discussion that is very much worth having. The other thing that is holding us back is kind of ironic. It's storage cost. So if, one of the many sort of reasons to use a traditional CRUD model and not storing all old data is because data tends to accumulate. And everyone is sort of worried about the cost of keeping all of that old data alive and accessible, right? But it turns out that over the last 20 years, 30 years, the cost of storage has dropped like below the floor. Right? If 10 or 15 years ago, having a data set of 1 terabyte would have been considered not insubstantial and not a trivial undertaking, nowadays you get a terabyte of data on your SSD on your laptop. Right? That is an almost trivial amount of data nowadays. So the cost of storage is so low that we no longer have to assume that this is not a discussion we can have. Right? This is an operational concern. You can actually put some numbers to it. How much data are we talking about? How long do you have to retain that? How much will it cost to retain all the data since the beginning of time? It turns out that for a lot of systems, it's not a big deal because most systems do not deal with multi-petabyte data sets, and storage is pretty cheap, right? So once again, this is a discussion worth having. There's a question here which says, how does event sourcing work with respect to the GDPR EU directive in which people now gain the right to be 100% forgotten? The answer to that, the short answer is I don't really know because I'm not that up on what the GDPR means, but fundamentally speaking, if you want to lose data, you can always add that as a first-class concept in your system. Nothing is stopping you from losing data intentionally if that's what you want. Right? That is as intelligent an answer as I can give. All right. So we have all of these things. We have the two major issues that are holding us back, being operational cost and consistency guarantees. It turns out that event sourcing, obviously, because that's the title of the talk, is kind of a better way of architecting most systems. There are use cases where event sourcing is a bad idea. I have not personally run into one. I concede that there might be instances in which this would be a bad idea, but I assert that for most of the types of systems that we end up building, this is actually a much better sort of default go-to architectural pattern than CRUD is. And the underlying motivation here is that there's I could not find an attribution for this quote. I did not make this up, right? But a database is just a view over its transaction log. So fundamentally, even your traditional RDBMSs do not just take in your commands and modify data on disk. The first thing a database does is it takes in your update, it writes a statement to its transaction log, and after the fact, it might merge that into its actual consistent view of data on the drive. Right? So if databases do this, maybe we ought to think about doing this as well. Which brings us to event sourcing. Event sourcing, fundamentally, is almost a trivial pattern, right? What it means is that instead of thinking of your data as sort of a live chunk of state that you modify, start thinking of your data in terms of events, things that had happened. Every entity, business entity in your universe, in your particular business domain, is a sequence of events. So one sort of very common and also trivial to understand example is a bank account, right? A bank account, your bank account, when you go into a website and look at your bank account, it's not your, it's not your current balance. It's all of the events that preceded that brought you to this balance. So instead of storing balance of $87 in your database, you might want to store a sequence of events, such as an account being opened, $100 being deposited, some withdrawals, et cetera, right? Having that is remarkably powerful, as we will see. The things to note about this idea: events are facts, right? These are things that had happened. These are concrete, recorded facts. And facts are immutable. Facts do not change, right? If I withdrew $25 from my bank yesterday, I withdrew $25 from my bank yesterday. This idea will never change. Nothing can happen that will make me withdraw a different amount or make a deposit yesterday at the same time, right? This is a thing that had happened. I'm recording a record in my database stating that fact. And events are forever, right? If, I don't know what year this building was built on, right? But that is a recorded historical fact that will never change, will live on forever. Even in 200 years, when Martians will have conquered the Earth and demolished all of the buildings here, right? This building will still have been built at a certain date in time in this particular physical location. So events live forever. And those three fundamental ideas are core to event sourcing and are actually very, very useful ideas. The sister pattern for event sourcing is called Cqrs, which is Command Query Responsibility Segregation. That is also actually a remarkably simple idea. If your business entities are event streams, then writes simply append events to that stream. But it turns out that reads are actually projections of that data, right? Your balance in your bank account is a projection based on the sequence of events that had happened up until the point where you actually took a look at your balance. So that includes everything, full and partial selects. Okay, if you want your bank account balance, you need to aggregate all of these events. Partial selects, like if you're only interested in a subset of the data, that is also a projection. Views, joins, all of these things are projections over your data. And these are actually two separate concerns, right? Cqrs makes the assertion that reads and writes are completely different use cases, and they don't have to be built on the same schema or the same database instance or even the same data store, right? And extending that idea, your various read use cases are also separate from one another. You don't have to have a single store and a single schema serving all of your write and read use cases, right? This is it. It's just that. The recognition that these are separate use cases and you can actually treat them independently. And this is a remarkably powerful idea. So, is everyone sort of clear on these two ideas fundamentally? Right? I have not talked about implementation yet at all. We're getting into that in a second. But I want to make sure that these two ideas are understood. Cool. I did not see any confused head shakes. Right. So I assert that event sourcing plus Cqrs is a better architectural pattern than CRUD, which begs the question, better how? What does it give you? Well, it gives you tunable consistency, right? If you separate your reads and your writes, you can actually decide what level of consistency your reads give you, right? It is entirely possible to have one read use case that is fully consistent, that is totally what you've come to expect from your, MySQL or whatever reads, but it's also possible to have use cases where it's perfectly fine, plausible, even desired sometimes to have your reads sort of showcase stale data for a second or 10 seconds or a minute or a year. Right? You get to make that decision, and making that decision gives you very, very nice trade-offs per use case in terms of performance, in terms of data, in terms of complexity. The other thing that these patterns give you is they decouple your reads and writes. And it turns out that if you don't sort of mash all of these use cases together into one single data source, one single schema, you can actually scale your system way better. Because writes are remarkably simple. You just add something to a log. Whereas reads can be as complex as you like, but if you allow reads to be still and you have some sort of replication channel moving data from sort of your core event store to whatever read use cases, whatever projections you want to have in your system, you can actually twiddle that knob. You can actually make the determination of, you know, how important is this data, how important is the freshness of this data. You can actually sort of scale up your system, scale up your various use cases in your system independently. Wouldn't it be nice if you could scale your writes independently from your reads? Wouldn't it be nice if you could have independently scalable use cases like a fully consistent view for your sort of admin interface and an eventually consistent view for your, you know, bazillion users coming onto your web server day in, day out, right? You do not want to have the same scaling characteristics for these use cases. So event sourcing in Cqrs gives you a model where you can actually scale these independently. And finally, you get built-in auditing, right? And built-in auditing might seem like a fringe benefit, but actually, this is a pretty big deal because what this means is you can never get to the point where your data is corrupt in a way that you cannot reason about. You can never get to the point where you look at this data and say, I have no idea how we got here, let's try and figure out a smart way to fix it, right? That is no longer a possibility because you always have the full flow of information, the full flow of events leading you up to that corrupt state, and then you can make a reasoned, intelligent decision how to solve it, and you can add that to your test corpus. So this is actually a much bigger deal than it might seem on this slide. All right, enough theory, let's have a quick look at how you might implement such a system. Right, so circling back to our original premise of building the server for Wix ADI. Once again, it's a site builder. So fundamentally, our business domain is a user's website, right? What sort of use cases do we have, right? What are the actions that user perform on a site builder? Well, there aren't that many. The first use case you have is a user coming in saying, okay, well, this is a new product, I'm curious, let's try it out. Right? They start working on their site within your system. So you have this first event that you call site created, right? Simple enough. The next thing that happens is your users actually work on top of your website builder and they add stuff to the site, right? So just adding stuff to your site means a sequence of these site updated events, right? And you'll notice I'm being very abstract here and we will sort of bring it down to surface level very, very quickly. The third use case is shit. I made a mistake, right? I did something stupid. I might have deleted the site or I might have deleted a page in my site or something that I did not intend. I want to revert, right? So we have yet another event called restored. And you'll notice these arrows are basically state transitions, right? Certain events can only come after certain other events. Right? You cannot have a site update event if the site had not yet been created. Right? After a site is deleted, you cannot have any update event on it at all until it is sort of restored to an active state. So your site is not only a sequence of events, it's fundamentally sort of a finite state machine in of itself. And finally, your user might be done. You know, they might be bored, they might not have liked your product, or they might have liked your product very much, but after 3 years, they will have closed their business, right? They might want to delete the site. So that's also an event, right? So we have this very simple event model, and this is actually almost identical to the actual event model that we have for Wix ADI in production today, right? This is not oversimplified. This just leaves a few uninteresting details. right? So these are the 4 types of events that we have on our site, right? And everything that a user might do with their own website is encapsulated in this event model. I have no idea. Oh, thank you, Docker. In case you're wondering, this is not why you should not use Docker. There are very good other reasons for it. So, if we have this event model, for fuck's sake, where is my, sorry about that, 2 seconds, let me, skip this version. Whatever, I don't care. Brilliant. Okay, here we are, right? We have this event model in place, right? We have reasoned about our use cases. We know basically what sort of events we might accumulate for the given life cycle of a particular website. Now we can actually start architecting our system. So, we need some way to store events, right? We need some sort of whatever, data store, schema, whatnot, to actually store these events in a database somewhere. So what's in an event? Well, an event contains some entity ID, right? An event applies to a particular site. In our case, it might be a site ID, right? It might be a UUID, it might be a running number, it doesn't really matter. An event needs to have some notion of time, and there is a subtlety here, but the fundamental idea is that if the site is basically a sequence of events, therein lies an assumption, right? Sequence means that there is an order. Sequence means that events happen in a particular order. So I need some way to be able to determine which events happened after which events, right? So there is some notion of time here. An event would have some data in it associated with the event, so things like the actual event type. And the data might depend on the type of the event, right? So for an update event, I might need to have some sort of delta that I need to actually apply to the site. This is fundamentally when a user clicks save, I want to take the changes that they've made and store them. That might be a payload. It might be anything else really. That depends on your business model. And we would have some metadata associated with it. Things like the wall time for debugging purposes, or the user ID of the user who had generated this event. Some sort of metadata that is not sort of intrinsic to the event, but is meaningful for auditing purposes later, or debugging. So it turns out we can model this very, very easily with a very simple table on your favorite SQL database, right? We have 4 columns. One is the site ID, one is the version number, one is the wall time of the event, and one is the payload for this particular event. And we're only indexing on the top 2, the site and the event version. Now, what do I mean by version? For some reason, I used to have a slightly different version of the slide. I'm a little bit confused. There was supposed to be a little bit of an asterisk right there next to time. Time is a fickle concept in computers. What this fundamentally means is although we humans tend to perceive time as being linear, computers don't actually do that. So you cannot use and should not and hopefully will never use timestamps as events. You cannot order events by wall time. There are very good reasons for this. I will link to a separate talk that discusses that, but do not ever use timestamps to order or version your events in a system. Okay, so we can use just an int, a running number, right? The order is just 0, 1, 2, 3, 50, right? That's simple enough. Does this make sense to everyone? Is there anyone who's thoroughly confused by this? So the question was, who's auto-incrementing that number? That number is not auto-incremented, and I'll hopefully circle back to this a little bit later. Your application logic that deals with that. Okay, there's a bunch of questions here. Are event source systems more complex than CRUD-based? Because eventually you need Cqrs, which is CRUD-based. I don't know what you mean by Cqrs being CRUD-based. Are these systems more complex? Not really. There's a learning curve associated with it. You need to learn a new paradigm. But it turns out that the systems you build start out as being only slightly more complex than CRUD and end up being significantly less complex than CRUD as you sort of accrue use cases. The event model kind of spells crud. It does. We'll get back to that in a bit, but it doesn't matter. And could you comment on how to avoid reading a full event history, e.g. read product blue sneakers from Nike versus product category shoes? I'm not even sure what that means. I'm sorry. I think I get the gist of the question, which is in the upcoming slides. So we'll circle back to that in a second. Right. We have a storage model for events. We now have the ability to store events in our favorite data store, right? If you're wondering, we use MySQL at Wix very heavily. We're quite happy with it. If we needed to scale it out in terms of the amount of data, we can use partitioning. It applies the same to an event source system as it does to a CRUD-based system. There is no magic here. So we have this table for events, and now we can start actually sketching an API. We can actually produce a service that allows us to, to have all of these commands. And you will notice that these commands are actually remarkably similar to CRUD, right? It's the same principle applies. You always want to be able to create a site, update a site, delete a site, and select a site, right? There are no surprises here. The difference is in how you model the data and how you store it, right? That is why event sourcing is an architectural pattern, not an API pattern. Now, we have these sort of pretty obvious commands, right? Create site, get site at the latest version, get site at a particular version for purposes of, various purposes like displaying old versions of the site and your admin interface. We want to be able to update a site, delete, and restore a site. Now, what's important to understand, and the reason I use this terminology command and not a terminology of endpoint or API, is that command is a very good word for it, because a command is a wish, right? A command is not a thing that had happened. It's a thing that I, as a user of the system, or as the client-side app of the system, these are things I would want to happen. So if a user clicks save, the site is not saved, right? The payload is, here is the delta, I want the site to be saved. And commands may be rejected for various reasons. Right? The command may be malformed. The command may refer to stale data. So for instance, if a user had the website editor open on one computer and then closed the screen, basically put the computer to sleep, went to another computer, edited the site, had a bunch of stuff going in, and then opened the first computer again, right? That computer, that browser window actually has a stale version of the site. So any updates it might issue assume an old version of that particular site, which is obviously bad, right? So you may want to reject saves from that stale version of the browser window, right? Commands may be rejected. Events cannot be rejected. Events are facts. These are things that had happened. Yes? So the question was, are the gets really commands? That is actually a good question. I would assert that yes, these are commands because I command you to give me the latest version of the site. It just happens to be very simple commands that are not likely to fail unless the database is down. But I think that's splitting hairs, right? That's semantics. Semantics matter, just not for this, I feel. Right. If a wish is granted, right, what is the result? The result might be 0 or more new events in the system, right? If an update command is satisfied, the result will be an update event being recorded onto the database. And once it's recorded onto the database, once it's an actual event, then it will never change. That is a fact. That is a thing that had happened. So, with these things in mind, we can now start modeling our architecture. And the first version of our architecture is actually remarkably simple. We have our client app. It issues a command against, this is my terminology. You might find different terminology for other people. DDD has sort of its own terminology. I will not necessarily recommend you go and read the DDD book because, especially if you're sort of just getting into this pattern, the DDD book will cause you to over-engineer the shit out of your systems, right? It's not that it's not a good set of ideas. It's that you don't need that just yet, right? There are extensions to this pattern that are very valuable, but you don't have to start with them. Your first event source system can be ridiculously simple. So we have a service that takes in these commands. We have some event store where we can actually store these commands and store these events, the resulting events, and read these events off of the event store. And we need some additional component, which I like to call materializer. It's a fairly common term, although there are other terms like an aggregator or whatever you want to call it. This is the piece of logic that is in charge with taking in a sequence of events and building up the actual meaningful business entity, right? So a site is not, as far as the client is concerned, as far as the web app displaying and letting you edit the site is concerned, is not the sequence of events, right? The UI doesn't care about the events. The UI cares about the current state of affairs, cares about the current blob representing that site, right? So you need to have some unit in your system that can actually read in these events and reconstruct the current state. At a particular version, that version might be the latest version. I like to call this a materializer. Any questions so far? Cool, let's move on. So, this is actually an almost complete implementation of an event source system for this particular business problem. But we still have some things we need to deal with. We need to deal with conflicting updates because we will have them, and we'll circle back to that in a second. We might have some performance considerations, might have some operational considerations. Let's try and tackle these in turn. The first kind of big concern that you might have is what do we do with conflicting operations, right? Conflicting commands. And this can happen for any number of reasons. It might be your user just clicking their mouse on your site, issuing a bunch of commands, and the network being asynchronous means that some of these clicks might issue commands that will arrive at your server at the same time. It might be that you have a failure in your network routing layer, and you actually had your HTTP packet duplicated and arriving twice, which as far as, which under certain circumstances might mean your server will actually see two separate and almost identical commands that conflict with one another. So this is a thing you have to deal with, realistically speaking, with any system. Now, there are three common strategies to dealing with these, and last right wins is by far the most common one because with CRUD, that is really almost all you can do. Right? If you issue update statements and you issue two separate update statements at the same time, you have a race, one of them will win, the other one will get thrown away. Or they will be performed in any order, but the old data gets thrown away anyway. Now that you actually have sort of a built-in audit log, right? The audit log is the first class concept in your system. This is actually a big deal. You have to deal with it in some form or other. So last right wins actually oftentimes is not the desirable strategy. The other thing you can do is through some optimistic locking mechanism, which looks exactly the same as you might have implemented over an RDBMS, you want to reject one of the two commands, right? One way of doing this is if you have a client app and it's showing the site at version 7, and you now have an update that is supposed to bring the site to version 8, but you have two of these, you can let one in and create version 8 and just reject the other. Right, if you have a mechanism that allows you to do that. So optimistic locking is another strategy. The third, these are sort of classes of strategies really. The third strategy, if you have the need for it and you can put the time into it and your business domain actually allows it, ideally you'd want to take in all of these conflicting commands and if possible, deal with all of them because sometimes you have the business domain know-how to merge these conflicts. The fact that you have two sort of technically conflicting commands, two technically conflicting save operations on your site, doesn't necessarily mean you have to throw one away, right? If you have two users building the site at the same time and they work on two separate pages within the website, maybe you can merge these two changes and you don't have to reject one of them, right? But this is sort of the golden standard. This is what you would ideally want to do. It turns out that it's actually not that easy to do and oftentimes not necessary, right? So once again, don't over-engineer, pick the simple solution that fits your business domain, which circles back to that original non-requirement that we have. We are not required to support multiple people updating the site at the same time, right? So no concurrent editing means we don't really have to deal with this. We can add optimistic locking and just reject commands that are conflicting. Pick one, throw the other away. The other major concern, and I think we're starting to run out of time, so I'm going to try and make this a little bit quicker. The other major concern is around performance. So updates are easy, right? Writes just basically append to a table. You don't have to worry about too much. There aren't that many indices. It's fast. Reads, though, for this system might be a big deal. So what do you need to do in order to have a read? You need to load all of the events for a particular site since the beginning of time. You need to feed them into the site materializer, and then you get basically a snapshot of the state of the current state of the site, right? This thing, the all events since the beginning of time, might hurt. How much will it hurt? Well, that depends on your business model. So in our case, for Wix ADI, over the lifetime of a site, we might have easily in the thousands of updates, right? Users build their websites, they add stuff, they change stuff, they modify stuff for years sometimes, right? We might actually have hundreds, maybe even thousands of events coming into the system that we need to deal with, right? Events never die, so we have to deal with all of them. And this can actually be very, very painful. So you need to ask two questions. The first question is how many of these events, and the second is how big are these events? Once again, this being a site editor means we actually deal with quite a bit of data, right? Text, components, metadata, all of this stuff. So for the purposes of this discussion, let's assume 10 kilobytes times 1,000 events. 10 kilobytes times 1,000 events over the lifetime of a site mean you need to read in 10 megabytes of data just to build up the current state of a site, right? And it might be a lot more than that. That is actually not desirable. 10 megabytes might not sound like a huge number, but you multiply that by the amount of users you have, this starts growing very, very quickly. So we need some model for reading in which we don't need to read in all of these events since the beginning of time, and we don't put all of that pressure on the network, on the database, on our app servers, on our clients. Naive reads will not work for this. A very common, very basic, and very simple sort of follow-up pattern is to use snapshots. Now, if we circle back to Cqrs, you might remember that reads are distinct from writes. Your read model, your read data store, your read schema doesn't have to be the same as your write schema. We can use a different store and actually provide better performance. What we will do is we will use snapshots. So if this is the event sequence for a particular site from V0 to V whatever, right? We can have a strategy that says, well, we want to take every, say, 4 or 5 events and collapse them into an intermediate representation of the site. And because events are immutable, transitively, snapshots are immutable as well, which means that snapshots are ephemeral. What this means in practice is if, as you're reading in events, you actually do a lookup, and you want to say, okay, I need the site at its latest version. What is the latest snapshot I have, right? And it's pretty recent. Say you've had 10 events since your latest snapshot. You need to read the snapshot and just those 10 events. And you can reconstruct the full state from there, right? This gives you a very nice knob that you can twist in order to trade off space for performance, right? You can trade off the sort of tail size against how much storage are you willing to put in for the purposes of optimizing your reads. And this is strictly an optimization. The nice thing about this is because you have all of these events, you can always just wipe out your snapshots and try a different strategy if you found that your current one doesn't work for you, right? You can always change it. And if you lose your snapshot database, that's not a big deal because you can always reconstruct the state based off of the core event model. This turns out in practice to be a remarkably powerful pattern, and we've actually just recently found that our snapshot strategy that we originally put in place for Wix ADI literally blew up our database because we were saving too many of them. Because yours truly happened to be stupid while designing the system and chose a very naive and simply not a good strategy for our purposes. We did a truncate table, we put in a different strategy in place, no one knew, right? There was a bit of a performance hit for reads for a while until we, whether lazily or eagerly, reconstructed the snapshots. No one noticed, right? Our users were not affected, and we managed to, within half a day, get back to very, very good read performance for our users, just based on this thing with no downtime. So this actually turns out to be a very, very, very strong pattern. So if we add this, what does our architecture look like now? Well, we have the same front end, we have the same service, and you can think of the service as the thing orchestrating everything that's going on in the system, the event store, the snapshot store, the materialization, all of these things. It's a coordinator, essentially. We added this concept of a snapshot strategy, and I would recommend starting with something remarkably stupid, like create a snapshot for every 10 events or something like that, because you can always change it. You can always truncate the table, put in a different strategy, you're good to go. You don't even have to take your system down for that. And now we have two stores. One is the event store, the other one is the snapshot store, right? These can and probably should be two separate schemas, two separate databases. This one might not even be MySQL. You might have a better tool for the job, right? You can make that decision, whereas before you had this one canonical source of truth that had to do everything. And it turns out that that is actually a remarkably powerful thing to have at your disposal. So, wrapping up, lessons learned. Event sourcing and Cqrs, as with everything, it's a trade-off. It's not a silver bullet. Right? There's a learning curve associated with it. This is not how you're kind of used to building systems. I guarantee it, if you build it yourself from first principles once or twice, you're going to be at least as comfortable with it as you are with CRUD. Probably more so because there are so many inherent advantages to building systems this way. The other disadvantage is increased storage cost. Like I said, for most systems, not really an issue. And it gives you more knobs to turn, which is a blessing and a curse, right? It gives you more flexibility in designing your systems, but it also gives you the responsibility of actually twisting those knobs to suit your use cases, right? You can't ignore those knobs anymore. So it's a trade-off. You should think about it and you should make this trade-off wisely. But I would advise each and every person in this room to try to find a small feature or a greenfield project that is not necessarily in your critical path. Try it out. And don't use frameworks for this, right? It took us years to learn that ORMs are a bad idea for CRUD. Don't make the same mistake for this pattern. You don't need a framework. You just need common sense and a little bit of elbow grease to get started. And once you build it once, it actually turns out to be really simple. The other lesson is eventual consistency. Consistency is a trade-off, right? CRUD has the advantage that it provides you absolute guaranteed full consistency that comes with costs. It doesn't scale very well, and it's a mess to deal with down the road, right? Eventual consistency gives you all of this flexibility at the cost of responsibility. You have to start thinking about these things and having these discussions with your architects, with your product managers. So it's a trade-off. Make it wisely. Lastly, a few recommendations. With an event source system, you cannot ignore SLAs anymore. You need to start thinking about them explicitly. So things like latency and consistency requirements become first-class concepts in your architecture. You should have sanity limits on things like how many events can be stored. And you should have an if statement where if we have more than these events, we throw an exception because this is not the design of the system. And it's going to blow up in your face if you don't do that. You should invest in tooling, which you will do anyway, and which you have done for the last 20 years. You're just so used to it, you haven't even thought about it, right? Tooling for CRUD-based systems is almost trivial, and we all have these tools at our disposal. But for an event source system, you will actually have to start building a few of these yourself. I find it actually very gratifying to do that. For further reading, further learning, there's two talks I can recommend. One is a talk by Netflix, by two people from Netflix. They've built an event source system for downloads, right? Nowadays, they allow you to actually download movies. They built it on top of an event source model. They deal with a lot of organizational concerns there. and they talk about schema evolution specifically, which, by the way, is no different from a CRUD-based system. But they do talk about it explicitly, which I could not do in the scope of this talk. The other one is a bit of a shameless plug, and I apologize for this, but I mentioned before that you should never, ever, 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 ever use timestamps for versioning in any system. If you want to know why, this is as good a link as any. And with that, I am done. Everything we've talked about is fully implemented in Java in this GitHub URL. You can go have a look. It's Dockerized, but you can actually run it. It's bordering on production grade, which will hopefully help you make sense of some of the concepts I've described. I apologize for taking more of your time than anticipated, and we don't really have time for questions. But thank you very much. I am available after this. Have a great conference. Cheers.